Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 187. We are in the process of solving word problems. From day number 101 through 200, and today is our 87th day. The work that we're going to do today on day number 187, I want you to watch the video for yesterday's work, day number 86, and compare it against the work that we're going to do today. Here's the problem on the blackboard from yesterday. Yesterday the problem that we did was find two numbers whose sum is 30 and whose difference is 6. Here's the problem for today. It says find two numbers. Problem for today is find two numbers whose sum is 6 and whose difference is 30. Let's do it. That's our new problem, okay? So you and I will do it together and we'll see what happens. So here we go. Let S, it's difficult to read my handwriting sometimes. Let S be the small numbers. See, we have a small number and a large number. Small number, that's an N. That would imply that the greater number would have to be 30 more than S, 30 more than the small number. Greater number, let's call it G, would have to be 30 more than the small number. Why? Why does the greater number have to be 30 more than the small number? Because of the fact that we are told that their difference is 30. The only way you can have a difference of 30 is if the greater number is 30 more than the smaller number. If I tell you that the difference between the two numbers is 30, then if the small number is 30, the large one would have to be 60. If the small number is 100, the large one would have to be 130. That's the only way you're going to get a difference of 30. If the small number is 5, the large number would have to be 30 more than that, 35, in order for their difference to be 30. So whatever the small number is, the greater number G is just 30 more than that. That's it. And now we are told that their sum is 6. Right here, their sum is 6. So let's write that in the equation. Their sum is 6. So we have the small number plus the greater number, and we are told that their sum equals 6. The small number is S, the large number, the greater number is 30 plus S, and that equals 6. S plus S is 2 S's, plus 30 equals 6. Let's subtract 30 from both sides. This drops out and we end up with 2 S's equals 6 minus 30. I'm trying to do it in a hurry and I don't like it. So here we had a positive 30, here we have a negative 30. So positive 30 and negative 30 drops out. And here we have a negative 30 and a positive 6. A positive 6 and a negative 30 is going to give us negative 24. We're not done yet quite. We have to solve for S. This is 2 times S. So let's divide both sides of the equation by 2. Divide both sides of the equation by 2, and as a result, we need to bring down this equal sign a little bit. These 2 cancel out. That's the whole point. And S equals negative 24 divided by 2, which gives us negative 12. And what does negative 12 represent? That's our small number. The greater number is 30 more than that. Therefore, let's continue here. Greater number is 30 more than the small number. Small number we found to be negative 12. So it is 30 minus the 12, negative 12, that is 30 minus what it is technically is 30 plus the small number, which is negative 12. 30 minus the 12 is 18. Our large number is 18, our small number is negative 12. Let's make a note of it here. The greater number is 18, the smaller number is negative 12. Now what we're going to do is solve the same problem by using another method called simultaneous equation. See what happened in this method is that we only have one variable. We actually had two variables, s and g, but then we define g in terms of s by saying that greater number, whatever it is got to be 30 more than s because of the fact that their difference is 30. And by doing so, we have the entire solution in just one variable, in terms of just one variable, s. There is another method which is called simultaneous equation method, where we do not have to define one variable in terms of the other. We can leave the two variables separate and solve for them independently by using two equations. Let's do that. I need the room. I need a great deal of room, so I need to erase everything. So we're done with this method. Okay? And here's the solution. Simultaneous equations method. What happens in the simultaneous equation is that we're going to have two variables, s and g. S and g, small and large, and we are told that their sum is 6. So small number plus the large number equals 6. Small number plus the large number equals 6. We are also told that their difference is 30. And if in order to express the difference as a positive number, we have to put the greater number first. The greater number minus the smaller number, that difference is 30. And since s is here and this s is here, they are not lining up, and this g is here and this g is here. So instead of writing the first equation as small number plus the greater number, let's put that as greater number plus the small number. So it's the same thing. Greater number plus the small number equals 6. Because of the fact that their sum, we are told, is 6. So here we have our two equations. This is equation 1. This is equation 2. And they are called simultaneous equation. Why are they called simultaneous equations? Because of the fact that whatever value that we claim that g equals to, and whatever value that we claim that s equals to, has to satisfy both of this equation simultaneously. What does it mean to satisfy an equation? It has to hold true for it. For example, if I tell you that 3 plus x equals 7, then x equals 5 does not satisfy this equation. The value, if I claim that x equals 5, that does not satisfy this equation. It does not hold true for it. If I claim that x is 0, that does not satisfy this equation, because 3 plus 0 does not equal 7. What value of x will satisfy this equation? That's the mathematician's way of saying, what value of x will make this thing work? Well, the value of x that will make this equation tick, if you like, what value of x will make this equation tick? The answer is 4, because 3 plus 4 equals 7. Therefore, 4 is the value of the variable that will satisfy this equation. That will satisfy that equation is just a fancy way of saying it will make it work, it will make it tick, if you like, in the colloquial sense. You understand? I just used the word, I'm not sure if I want to go there. I don't want to go there because I don't have my list with me. Unless you want to, let's finish it up, okay? So let's add up the two equations. Here we have positive s, here we have negative s, and they drop out, positive and negative s. Plus g and a plus g, we have 2 g's equal 6 plus 30, that is 36. Divide both sides by 2. Divide both sides of the equations by 2. And as a result, we need to bring this equal sign a little bit down. This 2 cancels out with this 2, and g equals 36 divided by 2, which is 18, which is exactly what we found here. G equals 18. Now to solve for s, we can use either the first equation or the second equation. The first equation, equation number 1, implies that s should equal 6 minus g. 6 minus g. 6 minus g, which is 18. 6 minus 18 is minus 12, negative 12. Or we could have used second equation. Second equation, equation number 2, implies that s equals, this is a negative s, bring it to the other side, it becomes positive. So s equals s, and then bring 30 to this side, g minus 30. And if you do not know what I just did here, slow down and take your time and just solve this equation, second equation for s. That's what I'm doing here. If you solve the second equation, equation number 2, for s, negative s, you make it positive by adding s to both sides, and this s ends up here, and then subtract 30 from both sides to get rid of this 30, and you will find that s equals g minus 30. G minus 30. How much was g? G is 18. 18 minus 30 is going to give us negative 12. You see, we get the same value for s, obviously. It doesn't matter whether we use equation 1 or equation 2. Obviously, we're going to get the same value. Small number equals negative 12, and the large number equals 8. Because of the fact that the small number equals negative number, the small number is a negative quantity, negative 12, and the large one is 18, therefore their difference is 30. Because the greater number is 18 units to the right of the 0, and the small number is 12 units to the left of the 0. Therefore the difference between the small number and the large number, the distance is 30 units. But their sum is only 6, because positive 18 and a negative 12, when you add them together, you get a positive 6. There you go. Their sum is 6, but their difference is very far apart, it's 30. That in itself tells us, when that happens, where the sum of the two numbers happens to be a very small quantity, but we are told that their difference is a very large quantity, that's your cue, that's your hint, that one of them is negative. One of them has to be negative, because one is sitting on the left hand side of the 0 and one is sitting on the right hand side of the 0. Therefore their difference is a huge number, but when you add them up, because of the fact that one is positive and one is negative, when you add them up, the difference is very little. The difference between positive 100 and a negative 99 is only 1. Or rather, not difference. When you add them up, their sum, when you add them up, when you add a positive 100 and a negative 99, their sum is only 1. But their difference is 199, because negative 99 is sitting to the 99 units to the left of 0, and positive 100 is sitting 100 units to the right of 0. Therefore they are 199 units apart. But their sum is only 1, because negative 99 and a positive 100, they come out to be 1. That's all. We are done for today. I will see you tomorrow on day number 188. Alright? I'll see you then. Bye bye.